Hello guys, let me introduce self-paced CCDE course. This will be mainly for the CCDE practical exam, but it will be helpful for the CCDE written exam as well. You will see down below lots of quizzes, CCDE design quizzes, many questions similar to the CCDE written exam. Of course, not the same questions. Not only the questions, but mind maps and also technology comparison charts will be helpful for the CCDE written exam as well. I will introduce in this video the video content of this course, okay? This is the course outline. I will start with the layer 2 technologies, okay? And in the exam, the percentage of layer 2 exam questions, layer 2 technology exam questions should be around 10% or less, okay? 5 to 10% I can say. And basically I will go through spanning tree, all the modes of spanning tree, per VLAN spanning tree protocol, RSTP, MST, why you should one, not the other, what are the capabilities of each of these protocols. And then I will talk about, from the design point of view, the first of redundancy protocols, HSRP, VRRP, GLBP. I will explain the basics as well. Very fast I will go through, then I will compare them. All comparison will be based on design. There will not be any configuration comments or something like that. You don't need to memorize anything like how HSRP, what's the HSRP or VRRP multicast address. I don't remember, you don't need to remember. And then I will talk about some layer 2 and layer 3 access design topics, like what is routed access design, why it is important, and compared to layer 2 access design, what it can provide. When you don't have spanning tree, what would be the advantages, or what about layer 2 access, loop access and loop free access design? If you cannot spread the VLAN everywhere, what would happen? Then I will also explain in the layer 2 technologies interactions. When you use layer 2 based access design, you will always have first of redundancy protocols. If you are using layer 3 access design, you don't have to use first of redundancy protocol. Now spanning tree can be there, first of redundancy protocol will be there, and probably on top of that you will also run for the northbound traffic layer 3 protocols. Now what would be the interactions between them? Okay, when spanning tree fails, when the access link fails, what would be the impact on the core of your network or wide area network? Okay, or when something fails in the maybe core node or aggregation node or link, what would be the effect? How you would create black holing or routing loop or suboptimal forwarding? I will explain those kind of things. Then I will introduce, actually this will be the most detailed lesson, IGPs. And in this self-paced course, you will see separate OSPF lesson, ISAS lesson, EIGRP, and BGP lessons. In each one of them, you will have at least 3 hours videos, theory, case studies, then quizzes, comparison charts, many things, okay? When you go to OSPF, for example, in theory, you will learn what is single area design, what is multi-area design, OSPF LSA types, area types, again interaction with the other protocols like BGP and MPLS. Not only that, how you would migrate from OSPF to other protocols like maybe EIGRP, ISAS. Then in the case studies, also we will use them in a topology, in a scenario based questions you will see there. Then in the comparison charts, of course, like, okay, what's OSPF single area versus multi-area design considerations, or OSPF version 2 versus OSPF version 3. These kind of comparisons are very important in real life as well as in CCDE exam, guys. Especially practical exam, you will have lots of comparison based questions. Same thing I will do for the ISAS, EIGRP, BGP, all the other topics as well, like MPLS, like IPv6 quality of service multicast. First, technology based, so you will understand the theory. Even if you don't know today anything about design, you will learn, okay? Then case studies, then comparison charts. Of course, once we finish this, all these, I am calling them technology-based lessons, then we will go through the scenarios in the self-paced course. Once we understand all the technologies, we can use our knowledge in the practical scenarios. You will have 3 practical scenarios in the self-paced course. I think it is more than enough to understand how to approach the CCDE practical exam questions and which type of questions you might see in the exam, and there are also lots of technologies you will learn throughout the scenario. Okay, in MPLS, mainly for the MPLS VPNs, layer 2 MPLS VPNs, Ethernet over MPLS, EO MPLS, then VPLS, EVPN, provider backbone bridging EVPN, then layer 3 MPLS VPN, then again theory it will start, and case studies and comparison like MPLS layer 2 VPN versus MPLS layer 3 VPN. Interest VPNs I will explain in detail, option A, B, C, D, or option A, B. MPLS traffic engineering, use cases I will explain how it works, comparing MPLS traffic engineering with the other traffic engineering like IGP and BGP traffic engineering. Not only comparison, but also in IGP you will understand how with the metrics you can do IGP traffic engineering, or in BGP how with the BGP pet attributes, BGP attributes you can do BGP traffic engineering. Then in MPLS how with the RSVP TE and with the tunnels you can do MPLS traffic engineering. Or in MPLS traffic engineering I will also explain FRR, fast reroute, and I will explain in IGP sections IP fast reroute without using MPLS RSVP TE. Then in MPLS traffic engineering FRR I will compare all of them, like loop free alternate you will learn, RLFA, remote loop free alternate you will learn, directed LFA you will learn. Then couple other things like maximally redundant trees also I will explain. When I explain MPLS traffic engineering fast reroute, we will be able to compare all of them. You will also see at the end of the course, I think, self-paced course, segment routing FRR as well. So now you will compare 5-6 different fast reroute techniques, so on and so forth. Carrier supporting carrier also I will explain how this architecture works. This is an architecture basically. By just using in a different way, I can say, we will create an architecture. Why we may need to do this in real life example I will also give, and one of my customers, they had to do this, and why you need to do this, and there might be better architectures how you can migrate, so on and so forth. You will learn. I will also VPN design, probably 10% of the exam from these technologies might come. I will explain GRE, and there will be also MGRE here. I didn't add GRE, multi-point GRE, IPsec, DMVPN, GetVPN, L2PV3, Lisp, and there are other also VPN in the VPN design. There are other technologies as well. You might just go down and you will see what are the technologies in VPN design. I'll go through quality of service design in IP and MPLS. I will explain the unified versus short pipe versus pipe, or it's also known as long pipe. In MPLS quality of service, diff-serve tunneling modes, and I will compare them. In IP, I will explain the quality of service tools. Then I will introduce congestion avoidance, congestion management mechanisms, some quality of service best practices you need to understand, because quality of service questions in exam, in CCDE practical exam, generally you might see individual type of questions, like without looking the business requirements, you might answer some questions. It's same with the multicast. If the question requires to answer based on the business requirement, then it's not an individual question. You have to answer based on the business requirement. Same thing with the multicast. In multicast design, I will go through mainly protocol independent multicast, and there are different deployment models for the protocol independent multicast, like PIM-ASM, PIM-SSM, PIM-BIDER. All of them, they are also known as PIM sparse mode technologies. I will explain, of course, PIM dense mode first, then PIM sparse mode, and in PIM sparse mode we have PIM-ASM, any source multicast, PIM-SSM source specific multicast, PIM-BIDER, and how we can achieve the redundancy, how we can achieve the load balancing, how we can achieve the phase convergence. I will introduce MSTP, what's MSTP, what would be the design considerations if you are using MSTP, and also Anycast RP, what is Phantom RP, and how you would compare Phantom RP, Anycast RP, etc. We will understand. In security design, I will go through the infrastructure security mainly, because in exam, guys, this is very important. You will not see wireless questions, you will not see collaboration, you will not see voice, and you will not see many security questions. There might be couple only security questions, but not from wireless, collaboration and voice definitely, but from security there might be something, and they will be very basic, trust me, and basically infrastructure security, like where we should put the infrastructure access list, where we should do the RTBH, remotely triggered blackhooling, so on and so forth, basic stuff. Shall we access to the router through telnet or SSH? Okay, you got my point. In IPv6, I will explain IPv6 addressing plans. I will in the theory section, then case studies, and I will explain IPv6 over IPv4, IPv4 over IPv6, all this transition mechanism, tunneling mechanism. Then I will explain also dual stack, how we can use IPv4 along with the IPv6 together. It's called dual stack. Also, I will go through some translation mechanism, not PT, not 64, DNS 64. Then, of course, quiz questions. For each and every lesson, I have also quiz. Once you complete the OSPF design lesson, for example, you should go and take the OSPF design quiz. Once you finish IPv6 design, you should go and take IPv6 design quiz, and you should verify what you have learned. Then you should assess yourself. This was only the video lesson topics. Okay, please check what else we have in this CCDE self-paced course, because not only the video content and how you should use them, what should be the order, please check other introduction videos.